Lesson 5 NF4, we're going to talk about multiplying with fractions. So when we're done with the lesson, the hope is that we can multiply with fractions and multiply with mixed numbers. So let's take a look at our vocabulary. So that vocabulary is very much so the same as Lesson 5 NF1. So we are going to practice it, and then if you did not have to go through Lesson 5 NF1, then you still want to make sure to go through these, so that way you are very sure about what the words mean, so when we talk about them, you are not confused. So here we go. This time I'm going to give you the definition, and you want to try to guess what the vocabulary term is, and then you're going to write it down on the line in your notes. And the order of the definitions on the video will match the order of the definitions on your notes. So here we go. A number expressed in the form a over b, where b does not equal 0. Well, if you guessed fraction, you are correct. So a over b might have been your giveaway because of the fact that it looks like a fraction. All right, so fractions are in the form of a over b, and they tell you how many parts out of a whole you have. The next one, a whole number with a fraction. If you guessed mixed number, you are correct. So you have a whole number that tells you how many whole groups you have, and that is connected to a proper fraction. That tells you how many parts you have. Right, so that is a mixed number. So then here is a visual representation of that mixed number, which might be helpful for you. So this right here is 2 whole groups, but then you have that 1/3 that is left over. The top number in a fraction, and it tells you how many parts you have or how many parts are left over. All right, if you guessed numerator, you are correct. That numerator tells us how many parts we have out of the whole, so in this case we have 3 slices left out of 4. When the numerator is larger than the denominator. If you guessed improper fraction, you would be correct. Improper fraction. I will spell that for you. So improper fraction. And I like the picture here too, because it shows you. So here we have 7/4. So here's a 4th, and here's a 4th, and here's a 4th, and here's a 4th. And then 3 more of them are shaded in. So altogether we have 7 of them, and they're all the size of a 4th. That's what an improper fraction is telling you. All right, and then the bottom number in a fraction, it tells how many make a whole group. If you guessed denominator, you are correct. And there's that pizza again. So now the denominator, in this case, is 4. It tells us that if we wanted to have a full pizza, we would have had to have 4 slices there. All right, so let's take a look at what's happening when we multiply with fractions. So in here, you're going to draw a picture of what's going on. We're not going to do any of the math. We're just going to show a model. All right. So we have 1/3. So to make 1/3, so we have our box here, and we're going to split it into thirds. So then now, and I did that because of the fact that I have thirds right here that I'm working with. And I'm only looking at one of those thirds. I'm only looking at one of these. However, what I do to one, I have to do to all. So we have to remember that golden rule. What you do to one, you do to it all. So then the next thing is I'm looking at 4ths. Okay, I'm not worried about the fact that I'm looking at 2 of them, but I know that I also have to split this box into 4ths. So let's just pretend we didn't split it into thirds and split it in 4ths going the opposite, or going horizontally instead of vertically. Oops. There we go. All right, so now I've split it into 4ths going vertically, and then that's where the 2 comes into play. So for the 2, I'm only looking at 2 of those 4ths. So here's a 4th. Remember, it goes all the way across, and here's a 4th. My answer lies in that section that has both colors in it. So it's only these right here, and there are 2 of them. Now we have to look at how many total pieces there are, because there's not just 3 anymore like there were when we split it into thirds. When we took those thirds and split them into fourths, it actually made 1, 2, 3, 4. So we're counting each of the boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So each of these is worth 1/12. And I have 2 of them that have the same, or that have both colors. So the answer here would be 2/12. All right, so again, what you're doing is you're taking that first number, which would be 1/3. So you're just taking 1/3, and then you're cutting that into fourths, but you have to remember 1/3 is already smaller than a whole. So that's no longer, it's not worth 1 whole. So when you cut it into 4 pieces, those 4 pieces aren't worth fourths, they're worth 12ths. All right, 2 1/3 times 1/2. This one's going to look a little bit more complicated. So I have 2 1/3, so I have 2 whole groups and then 1/3 of a group. What I need to remember, and sometimes we tend to forget, is that these 2 whole groups are made up of, so these are 2 groups of 3. Write that down. So 2 groups of 3. So we broke them down into thirds. That's a really bad dotted line, but I'm trying my best here. Okay, so right now, if I was looking at this, I have 2 full groups of thirds and then 1/3 left over. Or I could look at it and say, okay, well, here's 1/3, and here's 1/3, and here's 1/3, which we know makes 1 whole. But then here's another, 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 and another. So altogether, I have 1, 2, 3, 4, 5, 6, 7 thirds that I'm looking at. Okay? So now, I'm going to erase those so it doesn't get confusing in a minute here. I am taking those 2 whole groups that are made up of thirds, and I'm cutting them in half. Just going to go ahead and slice them right down the middle, cutting them in half. Now, remember, the only section that we're looking at then is this section here. Okay, we're only looking at one of those halves. Now, remember, these were thirds, but now, because we cut it down the middle, now these are actually worth sixths. Okay, and I have 1/6, 2, 3, 4, 5, 6, 7. So my answer here is actually 7/6, and I know that these right here are going to make a whole group, because 6 out of 6 makes a whole group, so my answer is 1 1/6. All right, so we looked at what we're doing with a model. Let's look at what's happening mathematically. This is the beautiful part when it comes to multiplying and dividing with fractions. You do not have to have common denominators. So, no LCD. Yay! I know that makes us happy because that's one less step. And I won't lie, that makes me really happy. I like when I don't have to find that extra little piece right there. So now, I actually get to just multiply straight across. So I multiply both numerators by each other, and then I multiply both denominators by each other, and I end up with 2/12, and that is my answer. I really love multiplying fractions. It's actually really simple. All right, and the thing is, we can simplify it. If it asks us to simplify, I can take the 2/12 and I can divide the numerator and the denominator by 2. So we're making that equivalent fraction, and I get 1/6. All right, so let's take a look at the next one. Now, I want to remind you, when we multiply with our number, with multi-digit numbers, like if I did 12 times 14, I would do the 2 times the 4, and then I would do the 10 times the 4. And then after that, I would do the 2 times the 10, and then I would do the 10 times the 10. So I ended up making sure that I multiply all of my numbers by each other. I have to do that when I'm multiplying with mixed numbers. So a lot of times students make the mistake and they say, oh, okay, well, this is just going to be 2, and don't write this down, this is just going to be 2 and 3/16. That doesn't work. That's like looking at 14 times 12 and saying, oh, okay, well, 4 times 2 is 8, 1 times 1 is 1, so I get 18. When in all actuality, I end up with a much, much larger number. Okay, so you cannot do it that way. To make sure that all of our numbers get included and get multiplied by one another, I do have to convert my mixed number into an improper fraction. So we're going to go ahead and do that. So I have 2 groups of 4, which means I multiply them together because this is 2 full groups of 4. That gives me 8 pieces. And then I add 3 more. So that means, because in these 2 groups I have 8 pieces, plus the 3 left over means I have 11 pieces, and I'm still putting 4 into each group. Now I can go ahead and multiply because I know all of my numbers are going to be included. All of my pieces are going to be included. So here I have 1 times 11 is 11, and 4 times 4 is 16. There is no simplification here. So my answer is just 11/16. So let's give this one more try. Now I have 2 numbers that are mixed numbers, so I have to convert both of them. You have to convert. You can't just do whole times whole, fraction times fraction. That's again like doing 12 times 14 by doing 2 times 4 and 1 times 1. That does not work. So I have 2 groups of 2, which is 4 pieces, plus the 1 that was left over, so that's 5 pieces, and 2 go in each group. Here I have 3 groups of 2, because remember the denominator tells us how many are in each group. The whole number tells us how many whole groups we have, so we have 3 groups of 2, so that means we have 6 pieces, plus that 1 that was left over, which makes 7 pieces. And now I just get to multiply straight across. 5 times 7 gives me 35. 2 times 2 gives me 4. But I can't leave it like this because it's improper. So I'm going to convert back into a mixed number. So what that means is I'm taking these 35 pieces and I'm putting them into groups of 4. So I have 35 pieces and I'm dividing them into groups of 4. Well, 4 can't go into 3, but it can go into 35. And it goes into 35 8 times. So that means I can make 8 groups of 4. When I do that, I use 32 pieces. And when I use those 32 pieces, I have 3 left over. Notice those words, left over. Well, since they're left over, that means that's going to be my numerator. And then here I was able to make 8 full groups. Full groups of 4. So since these are my full groups, that is going to be my whole number. So that tells me that I have 8 full groups with 3 left over and 4 going into each group. Let's take a look at how to use this in word problems. So I have the members of a cross-country team, and they like to continue their training in the summer. And I know that Nero ran 1.5 miles in one day. All right, so Nero ran 1.5 miles in one day. Lily ran 3 times as far as Nero. So how far did Lily run? Well, there's my problem. 3 times what Nero did, and Nero ran 1.5 miles. So I know I have to convert this. I have one group of 2, which is 2, plus the 1 extra, which is, 3. So then this problem becomes 3 times 3 halves. But now what do I do with this 3? Because it's just 3. I have to make it improper. It's a whole number, so I have to make it improper. And to do that, I just put it over 1. Okay, so I have 3 over 1 times 3 over 2, which gives me 9 over 2. When I do my conversion, so if I have 9 pieces and I put 2 in each group, I can make 4 groups. So I know that my answer is 4 1/2. So then I know when I'm writing my answer as a complete sentence, I can put Lily ran 4 1/2 miles. Okay, and you can make a picture of that and see if it makes sense. So she ran 3 times as many. So if Nero ran 1 1/2, then 3 times as many would mean that you would have to have that many, right? Well, that gives you 1, and you have 1, 2, 3, 4, and then you have that extra half, so it's 4 1/2. So my drawing and my math match up, and they make sense, so I know that I did it correctly. All right, so let's go ahead and let's try the next one. Again, if you're ready to try on your own, you're more than welcome to. Just make sure you come back and check your answer, and make sure you're doing your ride. You don't have to highlight the question because each of the questions is separated out for you. So George ran, 3/4 times as far as Nero. So again, the problem in words spells it out for us in numbers. And then we know Nero was 1 1/2. So now he ran 3/4 times as far as Nero. So that actually tells us that our answer should probably be smaller because 3/4 is less than 1. And running the same as Nero would be like running 1 with Nero. So my answer should end up being smaller because 3/4 is smaller than 1. All right, well, I know that I have to make my fraction or my mixed number improper. And to do that, I have one group of 2. And that extra 1, so that gives me 3. So I have 3/4 times 3/2. 3 times 3 is 9. 4 times 2 is 8. And I know that when I do my division, I have 9 pieces, and I'm putting 8 in each group. Can only make 1 group, and I'm left with 1 left over. So my answer is 1 1/8. 1/8 is actually less than a half, okay, because when you think of a pizza, if you cut it into 8 slices, 1 slice out of those 8 is going to be smaller than if you only cut it into halves. Okay, so here, ran 1 1/8 miles. All right, and then we have Belinda. Belinda ran 2 1/3 times as far as Nero. So how far did she run? Obviously, I'm running out of some space here, so I'm going to come up off to the side, and I'm going to change my ink color because I forgot. So we're doing this one in green. If you have colored pencils, this is a great time to use them. So again, this is 2 1/3 times Nero's, and we know Nero's was 1 1/2. Both of these are mixed numbers, so I have to make them improper. By now, I'm hoping that we got this process down pat. Multiply the whole number by the denominator, then add the numerator. So here I have 3 times 2 is 6, plus 1 is 7, so I have 7/3, times 2 times 1 is 2, plus 1 is 3, it's 3/2. Multiply straight across, I get 21/6. I can't leave it that way. Since I can't leave it that way, I have 21 pieces, and I'm putting 6 in each group. 6 goes into 21 3 times. To make those 3 groups of 6, I use 18 pieces. And then when I subtract, I have 3 left over. So what that tells me is Belinda ran, so this would be 3 whole miles, and then this is my leftover, which would be 3 3/6, which we know is the same as 1/2, But we can leave it as 3 3/6. That's fine. And we would write out our answer. Belinda ran 3 3/6 miles. All right, so what I would like you to do is I'd like you to try these 3 problems on your own and have them prepared for class the next day or for our next class. And then I would also like you to just do this first application problem with Mrs. Farmer buying her cornbread. And then we will go over the second problem when you guys come back to class.